This is a helpful summary of the different types of isomerism that we've talked about. So remember, isomers in general, that means that we have the same number of carbons and hydrogens and oxygens or whatever. The molecular formula is the same. And therefore, the molar mass of the molecule will be the same. But sometimes we'll have the atoms connected in different ways, and so that we have different bond patterns, then those are called structural isomers because the structure of them is different. That's where you have a straight chain alkane versus, say, a branched alkane. Same number of carbons and hydrogens, but they're put together in a different way. If we have the same bonding pattern, then we end up with stereoisomers, having to do with just the orientation. They're all connected in the same way. You know, this example here would be 1,2-dichlorocyclopentane. Whether I have it in the cis or the trans form is just a matter of the position, but the chlorine atom is still attached to the same carbon, and so the bond connections are the same. So stereoisomers versus structural isomers. And then there are different kinds of stereoisomers. The first ones we talked about last week were conformers or rotamers. And those can interconvert. If you have a bond that can rotate, they'll rotate back and forth, and they can interconvert between one conformer and another. And what we talked about just now was these are also called configurational isomers, and these do not convert by bond rotation. They can only be converted by actually breaking bonds and then remaking them, taking it apart and putting it back together. So configurational isomers.